everyone, this is the summary video from side, 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 and side, angle, side. If you remember from when we were doing congruent triangles, we started getting a whole long list of congruency theorems. And what we're starting today is our list of similarity theorems. And you should recognize both side, 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 and side, angle, side as similarity theorems. But here's the pickle, and here's the really important part, is that the sides are no longer congruent. They are just all in ratio to each other. So, let me give you an example. If I have a triangle here, and I've got my bigger triangle here, okay, and I say that this is a 4, and this is a 3, and this is an 8, and this is a 6, I know that I'm probably looking at side, angle, side, because I've got side, angle, side, side, angle, side. So I'm probably going to be using side, angle, side here. But then what I need to figure out is, okay, is everything going to be in the same ratio as each other? So I need everything to be equal. So we're going to use that box that we were using yesterday. Okay? So this is the same side, and this is the same triangle. Okay? So, same side, 4 to 8. Same triangle, 4 to 3. Okay? Same side, 3 to 6. And then we cross multiply. And we should, if everything works out correctly, get the same answer. So 3 times 8 is 24. 4 times 6 is also 24. Because those two are equal, that means that everything is in the same ratio. So side, angle, side then works. Angles are still going to be congruent. But sides, you're going to have to use this ratio formula to try and figure out, are my two triangles similar? And then side, 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 instead of knowing this angle, you would just have a third side that you need to check. I'll see you online.